So hi guys, so welcome to our lesson on logarithmic differentiation. Just get a feel for what is logarithmic differentiation and how does it simplify our lives, especially when we're looking at some really complicated functions in mathematics and when we're asked to differentiate it. Surely this must be a simplifying technique. So I'm going to start off with some very basic problems and lead you into it, walk you through the whole process of logarithmic differentiation. So let's get started. Let's start off with something really simple. We've already been through implicit differentiation, and if you haven't, please watch the video. Make sure you understand what is implicit differentiation, because we're going to use implicit differentiation here as well. So let me start off with a very basic problem. Y equal to x. All right. We know the derivative dy dx is equal to 1. Now, let's take the logs or the ln on both sides. So we have ln y equal to ln x. Now we're going to differentiate both sides. Now remember, y is a function of x. Let's start off the easy one. If I differentiate ln x, the right hand side, ddx of ln x is 1 over x. What is ddx of ln y? Where y is a function of x. The inside function is y, so the derivative of y we write as y prime. And what's the derivative of ln of something? Derivative of ln of something is 1 over that something, and there we have it. So you have y prime over y equal to 1 over x, and we can add y prime is equal to y over x. But y is x. Ta-da! Does that make sense? So what's the big deal of logarithmic differentiation? Let's try another question. Y equals to x squared. Now take ln on both sides. Again, ln y is equal to ln of x squared. Now again, we know that dy dx is going to be 2x. Right, straight on. Y equal to x squared. So if I differentiate, now here you're going to be very careful. The beauty of this, you see it's quadratic. There's an x squared there, here. But we can write this as 2 ln x, correct? This sort of stuff we learned way back in primary school. So let's differentiate. If I differentiate the left-hand side, what is ddx of 2 ln x? That's nothing more than 2 over x. If I differentiate the left-hand side with respect to x, I'm going to get y prime over y. Okay, where did the y prime come from? The derivative of y with respect to x is y prime. The derivative of ln of something is 1 over that something. That's the reason why I got a y in the denominator. And we're going to go y prime is equal to 2y over x, but y is x squared, so it's 2x squared over x. And for sure as God made little apples, the answer is going to be 2x, which is what we expected. No big deal. All right. This one looks so much more difficult than that over there. Human beings, we conserve energy. So where's what's the word for this? Where's the assistance? Where does it make things easier for us? Why do we need to do this when it looks so much more difficult? Or is it just some mathematical excursion or excitement? Well, let's try another problem and throw you into the deep end now. Y equals to x to the power x. What's really happening over here? So take a look. If you wrote y prime is x times x to the x minus 1. No. That ain't it. There's no way that's the answer. It almost looks like it's correct. But remember, the power rule that you learned in school was we had x to the power n, where n was a constant, right, n greater than 0. This x is not a constant. So you can't apply that power rule that you learned in school. So naturally, we've got x to the power x, so we say ln y is equal to ln of x to the power x. Now you know what's going to happen here. It's going to be x ln x. So if I differentiate with respect to x, I'm going to get y prime over y. You know that's always going to happen. But here, it's a product. So if I differentiate, I'll have 1 times ln x plus x, and the derivative of ln x is 1 over x. So my answer here would be ln x plus x, that's 1. So eventually y prime is y into ln x plus 1, but y is x to the power x. So there's your answer. So the derivative of x to the power x is not that over there, but rather this over here. So y prime is x to the power x ln x into ln x plus 1. So you can see the power of actually using logarithmic differentiation. Let's try something else and see whether it helps us in some sense. I'm going to ask you to differentiate y equal to x plus 1 to the power 20 all over x minus 1 to the power 20. Okay, 200, like that. So you have a look at this and say, well, I can use a quotient rule. And when you use a quotient rule, things would work out quite nicely, quite easily. And also it's linear in x on the inside there. If you look here, it's linear there on the inside. So pretty straightforward, but the chain rule would apply. But if we take ln on both sides, watch what happens. Watch what happens. So it's ln of the entire thing, x plus 1 to the power 20 all over x minus 1 to the power 200. This, dear friends, ln of x plus 1, you can see where this is going, right? Minus or plus? Minus ln of x minus 1 to the power 200. Where did that minus sign come from? Yes, it's a quotient. Well, remember, ln of a over b is equals to ln of a minus ln of b. Now, here's the beauty of this. What happens to the 20? What happens to the 200? Correct. That becomes ln of x plus 1. 20 pops up in front, minus 200 ln of x minus 1. All right, now differentiate both sides. What do we end up with? If we differentiate both sides, we're going to get y prime over y equals 2. Now watch. What's the derivative of x plus 1? It's 1. What's the derivative of ln of something? It's 1 over that something. So this would be 20 times 1 all over x plus 1. This one you can guess is minus 200 times 1. Because the derivative of x minus 1 is 1. The ln of that is over x minus 1. And so we can write this down as y prime equals to y into, watch this, 20 over x plus 1 minus 200 over x minus 1. Of course, we know what y is. And you can also simplify here by taking a common denominator and make that look pretty. But essentially, that's your answer. That's pretty straightforward. What I will do is challenge you to use the quotient rule and see whether you get the same answer as what we have over here. And you would then appreciate logarithmic differentiation. Let's just quickly have a look at something like y equals to, what are you going to say? Sine cubed of 2x all over, give me. 1 minus root x to the power 11. I don't know why I even chose 11, but what? Let's try it. I need dy dx. If you have a look at this, you got sine cubed 2x, you got 1 minus root x over 11. You see the chain rule popping up there, the quotient rule as well. And I challenge you to use the quotient rule to get the answer. But let's try logarithmic differentiation. So ln on both sides. And I always like to write that out firstly. So you tell the examiner or the reader you've now taken ln on both sides. So you watch the use of square brackets. Yes, interesting. So if I differentiate both sides, not just yet. Just simplify the right hand side. So we're going to go ln. That's a quotient here, so that becomes sine cubed 2x minus or plus? Minus, yes. Ln of minus root x to the power 11. And we can go even further and say it's ln of sine cubed, which is 3 ln of sine 2x. Then pop the 11 in front, minus, and you know I always like to write root x as x to the power half like that. Beautiful. So we got ln y equal to that. So now we differentiate both sides, and if you differentiate both sides, you're going to get y prime, whoa, over y. Now what's the derivative of, let's go here, 2x. It's 2, so 2 times 3 gives me 6. What's the derivative of sine of something? Ooh, cos of something. And then what's the derivative of ln of something? It's 1 over that something. So simple. Minus 11. Now let's differentiate the inside. Be very careful here. 1 minus x to the power half. What is d dx of that? Yes, let's write it down separately. That'll be minus a half x to the minus a half. That's it. And what is d dx of ln of something? It's 1 over that something. And there we have it. So I'm running out of space here. And what we do then is we can sort of modify that, and eventually I can write y prime equals to y, this y I'm multiplying across, into what? Cos over sine, that becomes 6 cot of 2x, and the minus times minus has becomes 11 over 2. So we have 11 over 2, so that's a plus. And x to minus a half over that. You can write as x to minus a half, or you can write as 1 over root x into 1 minus. So this could be, let me just write it as x to the minus a half. Spaces of the essence here. 1 minus x to the power half, and close your bracket, and there's your answer. You can also replace that y with sine cubed 2x all over 1 minus root x to the power 11. Easy going, guys. Very, very simple. Anyway, y equals 2. Now let's take this as, which sort of questions would you like to see? Well, we could have, watch this, 1 plus x squared, all raised to the power 10, all over, give me. Okay, so we're going to go 1 plus e to the x raised to the power, give me that. Okay, let's go squared. So you can see things are a bit hectic here. They're going to ln of 1 plus x squared to the power 10, all raised to the power 10, all over 1 plus e to the x, all squared. Quotient rule, your challenge. My challenge to you, do this via the quotient rule. But I'm just going to throw in ln on both sides. I mean, ln y equals to ln, remember my square brackets, love doing that. Something's wrong here, missing a bracket there, yeah. So this becomes ln of 1 plus x squared, but that whole thing is raised to the power 10. And then we have 1 plus e to the x all squared. So it's ln of that whole thing. I should actually use a red bracket over there. Well, again, quotient there. So this becomes ln of, woohoo, ln of ln. 1 plus x squared. But this is raised to the power 10 minus ln of 1 plus e to the power x all squared there. And now you can see what's happening. That's the reason why we use ln. So it's ln of 1 plus x squared minus 2 ln of 1 plus e to the x. Beautiful. Now, if we start differentiating both sides, starting with the left-hand side, if I differentiate here, I'm going to get y prime over y equals 2. Let's have a look at this guy. The innermost function is 1 plus x squared. What's the derivative of 1 plus x squared? ddx of 1 plus x squared, people? 2x. What is 2x times 10? That's 20x. Then we got ln operating on 1 plus x squared. What is the derivative of ln of something? Yeah, of course, it's 1 over 1 plus x squared. Then we have ln operating on ln of 1 plus x squared. No prizes for guessing here. The derivative of that is nothing more than 1 over. See, ln of something, the derivative of ln of something is 1 over that something. Easy peasy. Now let's have a look here. The innermost function here is 1 plus e to the x. What's the derivative of 1 plus e to the x? Yes, it's e to the x. So this becomes minus 2 e to the x. And then what's the derivative of ln of something? Hey, it's 1 plus e to the x. And there we have it. So if you want y prime, we're going to multiply across by y. You're going to simplify and you have a beautiful, beautiful answer. I could possibly write it out here for you. So y. Okay, so we're back and then we're going to have y prime over y. I just thought I'll have a new slide here. So just to make it more beautiful. How did we go from blue to red? So we had 20x all over 1 plus x squared multiplied by 1 over ln into 1 plus x squared. If you remember, minus 2e to the x all over 1 plus e to the x. And we can tidy this up as well. And so eventually y prime is y into. So if you have, this is just 20x all over 1 plus x squared ln of 1 plus x squared minus 2e to the x all over 1 plus e to the x. And you can always substitute the original function y in there to write everything explicitly as a function of x. Beautiful. Okay, so let's have a look at just one more now, because I think you've established the methods pretty straightforward and you could knock yourself out by setting your own questions. So have a look at 1 plus, say, x squared raised to the power half all over. Yeah, they can sort of camouflage it. It gets 1 minus x squared, which is the cube root. So we can write this immediately as 1 plus x squared to the power half all over 1 minus x squared to the power a third, correct? Chain rule would be cool. It would be pretty straightforward, but let's just try the power of logarithmic differentiation. Remember my square bracket over there, 1 plus x squared to the power half 1 minus x squared to the power 1/3. And we can write this as ln of 1 plus x squared to the power half minus ln of 1 minus x squared to the power 1/3. And we can see the beauty of that. That becomes a half ln of 1 plus x squared minus a third ln of 1 minus x squared. And if I differentiate both sides, I'm going to get y prime over y. Innermost function is 1 plus x squared. Derivative of 1 plus x squared is 2x. So you're going to get 2x over 2. And you tell me, what's the derivative of ln of something? It's 1 over that something. Yeah. I don't even know why I did that. And then the innermost function here is watch 1 minus x squared. The derivative is minus 2x. And minus 2x times that becomes plus 2x over 3. Be very careful. And the derivative of ln of something is just 1 over that something. Okay, and then lastly, what you want to do then is go y prime. 2's will cancel, so you can have x, y into x over 1 plus x squared, beautifully done, minus 2x all over 3 into 1 minus x squared. And you can really tidy this up nicely if you take a common denominator. You can put out a common factor and all sorts of beautiful things. And you can also replace that y with the original function and be home. Brilliant. I challenge you to do this via Quotient Rule and see what you come up with. Very, very simple. Beautiful. So there you have it, guys. You should be proficient in logarithmic differentiation. Try it. Just have fun with it. And I think you're good to go. In fact, let me just squeeze in there. What is the derivative of y equals 2 to the power x? Very quickly. Oh, you're going to say, yeah, we're going to take ln y equals to ln of 2 to the power x. So ln y is equal to x ln 2. Ln 2 is a constant. Differentiating, getting y prime over y. Derivative of x is just 1. Derivative of ln 2, that's a constant, so you're going to have that. So what is y prime equal to? Y ln 2. But what is y? 2 to the power x. So the derivative of 2 to the power x is 2 to the power x ln 2, not just 2 to the power x. Awesome! Guys, I thought that was a really cool and a quick excursion into logarithmic differentiation. Hope you enjoyed that. But please practice, practice, practice. And I'm sure you'll get really good at it. So we'll see you on the other side of 11, whatever that means.